Greetings to all. I am A.S. Kashyap and I'm one of the teaching assistants for the course for CE67 Foundation Engineering. Welcome to the course, and we will be having these interactive sessions weekly. Uh, two interactive sessions will be conducted, one by me myself and the other one by Mr. Shiv Shankar. My session will be on Monday, 6 p.m. to 7 p.m. and Mr. Shiva Shankar's will be on Saturdays, 6 p.m. to 7 p.m. And the course instructor for the course is Professor Kousik Deb from Department of Civil Engineering. And yeah, so this course we can utilize to share our doubts, and we will be solving some problems which is relevant to the course as we progress through the different weeks, and it will hopefully help you for the better understanding of the content. Okay, so in this session, I have prepared for us a few questions that was posted as part of week 0, and this is trial run. Uh, we'll try to solve a few questions. The first question I'm planning to the first question will be regarding compaction. Okay, so the question is, for a unit volume of soil with the increase in compactive effort, which of the following is true? So here we are asked how the trend of the optimum moisture content and the maximum dry density goes when we are varying the compactive effort. So when we talk about compactive effort, we are familiar with two different types of compaction tests. One is standard Proctor and modified Proctor. The only difference is the compactive effort you are providing to the soil per unit volume. So uh, the idea is okay. So in this graph which is shown, we have two curves which shows standard Proctor test results and the modified Proctor test. So it's quite clear that uh, here standard Proctor, when we talk about standard Proctor and modified Proctor, it's the basic difference is the compactive effort, as I told. So we can say express compactive effort as the amount of energy imparted during compaction per unit volume of soil. So if we compare, so in order to, if we want to compare these two, we can, the amount of energy can be obtained by multiplying the weight of the rammer used, the number of layers, the number of blows provided for each layer, and the thickness of each layer. And unit volume of will be the so we can, if we divide it by the volume of the sample, we can get the compactive effort. So if you compare modified Proctor and standard Proctor, it will be like 4 times. So the standard Proctor test, uh, sorry, the compactive effort of modified Proctor test will be almost 4.55 times of standard Proctor test. So you can see in this curve, we it's quite clear that we need lesser moisture content to achieve a great dry density. So we can imagine a line of optimums for different compactive efforts. So in this case, in all, if you connect those optimums, you can get this line of optimums, and you can see that as we are increasing the compactive effort, the dry density is increasing along this line, and the water content is decreasing. So our correct answer will be option B. Okay. Now moving on to the next question. Uh, the second question deals with consolidation settlement. So let us see here. They have given a soil profile A subsoil profile and the respective properties are shown as below. The water table of the is 2 meter below ground level. So let us draw the soil profile, and 2 meter below we have water table, and we have now that 6 meter below we have uh, another soil. So and 10 meter. It is said that soil fill of density 15 kilonewton per meter cube is laid on the entire area of the site up to the height of 4 meter above ground level. So above ground level, we have a new fill coming up, which is of 15 kilonewton per meter cube. The, the height of the hill is 4 meter. So we have a silt here. The first layer is silt as shown, and the second layer is clay. So the question is, if the void ratio of the clay is 0.8, so it's zero point 0.8, find the consolidated settlement of the clay layer, assuming that corrections are not required. And we can assume the water weight of the water as 10 kilometer per meter cube. So do you have any idea how to proceed for uh, the problem?
So I think only CC value is not given in the question, which we can find using the correlation with the liquid limit. Then all the other data are provided. We can go
Yeah.
with the formula.
Yeah. So the idea is, since the fill is the new thing that is being introduced, so there will be some extra new stress that will be acting on the clay layer. So we'll consider the middle of the clay layer, uh, so which is at a depth of let us say, so since this is total 4 meter, this length will be 2 meter. Okay, so we can find this because we know the density of this silt layer, both dry and saturated. We are given. So above the water table we can use this dry density. Below the water table we can use gamma sat. So and this will be the to find the initial stress. We can use these values, these data, and the change will be just because of this fill, which will be 15 into 4. So we have sigma, delta sigma. Now we know that we can find the settlement using the equation. Consolidation settlement can be written as mb into, there is a popular equation called this thing. This is the change in stress, and this is the depth of the layer. But alternatively, we can also use 1 plus E naught log of sigma naught plus delta sigma by here. uh, E naught is the initial void ratio. Cc is the coefficient of compressibility. This sigma naught is the initial effective stress. This stress is the stress that we are expecting at the middle of the clay layer, and delta sigma, as we discussed before, is the increase in effective stress at the depth at which we are interested. So this is the thickness of the clay layer. So here we know, the only thing we don't know is Cc, which is the coefficient of compression. So there are different before that, let us see how this equation came into picture. This equation came into picture by, we have, when we, if we are plotting void ratio versus uh, log of effective stress, what we get in the compression line is like this. We can get a linear line. If we are not using log, we'll get a curve. What is happening is, before consolidation, if this is the stress, and if you are increasing the stress by delta sigma, the void ratio is decreased. So the slope of this line is called CC. So if you are writing CC, it will be delta E, which is nothing but this value, and delta E by log of sigma naught plus delta sigma by sigma naught. And we also know that delta H by H can be written as delta E by 1 plus E naught. So if you use these two equations, this is only applicable for 1D consolidation. And if you are using these two equations, you can arrive at this formula that we are using. Here delta H is nothing but the S we are using here, the settlement. Okay, so how to find CC now? So there are different empirical relations found by different through research. Uh, Different equations are available. One of the most popular thing is by Terzaghi and Peck, in 1967. This is CC is given as 0.009 LL minus. So once we have this, since we have this equation, we can use it to find, we have the data, liquid limit of the clay given as 40. So we can use the correlation 40 minus 10. This will be 0.27. Okay. So we have CC also. Now if you plug all the values, we can get it. So but we have to arrive at our delta sigma and sigma naught. So let us find the initial stress, effective stress. So as we told before, before the fill was added, we had a water content, water level, water table at 2 meter, and till 6 meter we had silt. So silt saturated was 18 kilonewton per meter cube, and dry of the silt was 14. And so this is 4 meter, since 2, okay, so 4. And the clay layer is the the layer which we are interested is in the midway. So this will be uh, 2 meter, and this gamma sat is 19 kilometer. So we need to find the stresses at this depth. So initial stress will be, we are talking about effective stress. So above water table we can write just like 2 into 40. And what will be the below water table? Can you tell what will be the stresses due to the silt below water table and the top 2 meter of the clay layer?
Yeah, so 18 minus 10
Yeah,
into 4. this will be of silt, and 19 minus 10 into 2 meters.
Yeah. So this minus 10 because we are this is the gamma w which was given in the question. So here we are talking about effective stress. So effective stress we have to take care below water table whenever it comes. We have to take care of the density of the water also. So since we have this, the answer for this will be 78 kilonewton per meter square. So we have the initial stress. So but we have a fill which is coming, that is of 15 kilonewton per meter cube, which is of a height of 4 meter. So the increase in our, okay, I'll change the color. The increase in the stress because of the fill will be,
15 into 4.
yeah, 4 into 15, that will be 60 kilonewton per meter square. So we can, now I think we all have all the terms required, and the void ratio is already given, and the depth of the layer that we are interested, that is a h, is 4 meter. So our settlement can be written as h is 4 meter. So in order to get in millimeters, I'll write 4000 into cc value is 0.27, 0.27 divided by 1 plus E naught will be zero point 0.8 as mentioned in the question, 0.8, and our stresses will be initial stress, uh, okay, initial stress is 78, so 78 plus the increase in stress divided by the initial stress. So if we solve this, we can get 148.66 mm is almost equal to 149. So this is the answer D. Okay. Moving on to the next question. Uh, this question is related to consolidation also. So the question is straightforward. The question is like the time factor TV is dependent on one of the following. On which of the following? Coefficient of permeability, compression index, coefficient of volume change, drainage path. So here we need to understand one thing. Time factor TV is a quantity, is a non-dimensional quantity which we get after solving the Terzaghi's 1D consolidation equation using the boundary conditions. So TV is the thing that tells us the rate at which the consolidation is happening. For example, uh, so in this one of the options, which is compression index, that we know, we as we talked earlier, it shows the relation between void ratio and effective stress, normal stress. So but this has nothing to do with time. So this is actually independent. Let us see the other things. So in the after when we solve this Trezeguet's equation, we will get an expression like TV is equal to CVT by D square. Here, uh, this small t is the time taken for consolidation. D D indicates the maximum length of drainage path. Sorry, the minimum length of drainage path. And CV is the coefficient of consolidation. This is dependent on few more terms. Those are permeability. Since we are talking about vertical degree of consolidation, so vertical permeability and weight density of water or the fluid which is flowing through, and coefficient of compressibility. Now the options we have is coefficient of permeability. So time factor is in a way related to coefficient of permeability. Coefficient of volume change. Sorry, MV is the coefficient of volume change we have, and drainage path. Drainage path D is nothing but it shows the length of the drainage path. So drainage path is also dependent. So the options are A, C, D. So we have A, C, D, the D option. Okay, so problem 4, it deals with void ratio. So what's happening here is the question is asked like when a dense sand is subjected to shearing displacement, the variation of void ratio with increase in shear displacement, how will it look like? So whenever we do a direct shear test on a sand, we can get a result as we are seeing in the graph. So if it is a loose sand, as we are increasing the displacement, it will keep on getting compressed, as you can see. But if it is a dense sand, even if first it will compress a little bit, but after it has reached its maximum possible compression, uh, due to the interlocking, it cannot get compressed more. So it will begin to expand. This phenomenon is more popularly known as dilatancy. So what's happened is at the with the same normal stress, the volume is increasing. That is called dilatancy of sand. So this phenomenon is already found in dense sands, and so the options we have is first it reduces and then increases to a critical value. So this can be called as a critical value of void ratio. So here we have in y-axis we have volume change which indirectly indicates the void ratio, and in the x-axis we have horizontal displacement. So in direct shear stress, the horizontal displacement we mean the shear strain. So it indicates the shear strain. Okay, so the first option is fine for us. Second is first increases and then again it increases. That is not the case. And C and D is also not valid. So our answer will be A. So this phenomenon is because uh, there is a limit to which we can compress. So beyond that, if you can imagine a hacksaw which is uh, bound together, and if you are pushing one of the hacksaw against another at after some time to allow displacement, it has to move a little up. This is called dilatancy. So uh, in this case our answer is A. We'll go with one more problem that is related to Mohr circle. So in this problem, the question is the C5 soil is subject to a series of triaxial tests, and it was observed in one trial that the soil failed at a cell pressure of 50 kPa and a deviator stress of 180 kPa. If the cohesive strength of the soil is 15 kPa, find out the angle of failure. Failure plane makes with the major principal axis, principal plane. Okay, so since we have the failure point as this, and we have the center of Mohs circle here, so there is a way to find out angle of failure plane in the Mohs circle. So this is a failure envelope. And yeah, so this angle which the failure which the point of tangent is connected to the radial line, this angle is represented as 2 alpha. So whatever we have in the physical world, that is the specimen which fails in an angle of alpha, that is represented as twice the angle in our more Coulomb space. So we know that this is phi, and this is c by tan phi, which is, can also be written as c cot phi, and we have the sigma 1 and sigma 3. So let us see. From this figure, we can arrive at an equation. So if you look at this particular triangle ABC, in triangle ABC, if you are writing sine phi, in triangle ABC, if you are writing sine phi, what will be the numerator?
BC by AC.
BC by AC. Okay. So BC can be written in terms of sigma 1 and sigma 3. That is the radius of the Morse circle. So that will be sigma 1 minus sigma 3 by 2 and the denominator AC can be split into two. This piece AO, and this AO can be written as C by tan phi or C cot phi plus this OC, that is sigma 1 plus sigma 3 by 2. Now if you solve this uh, and okay, so we know that this is 90 degree, so this will be 90 minus 5, and we can also write like from the this angle 90 minus 5 plus 2 alpha is equal to 180, and we can write alpha is equal to pi by 4 or 45 plus 5 by 2. So if you use this relation in this equation, we can arrive at a equation like with respect to alpha, sigma 1 equal to sigma 3 tan square alpha plus 2c tan alpha. So in the question we are given sigma 3, which is the cell pressure, and deviator stress sigma d. So we know that sigma 3 is equal to 50
50.
kPa, and deviator stress is 180 kPa sigma d. So do you know how to arrive at the major principal stress?
Sigma 1 is sigma 3 plus sigma t. So 230 kPa.
Okay, so 50 plus 180, 230. So we know uh, sigma 1, we know sigma 3, alpha we don't know, uh, but C we can get. C is given as 15, so C is equal to 15. So if we substitute in this equation, we can get 230 is equal to 50 into tan square alpha plus 2 into 50 times. So if you are taking tan alpha as a variable, we get a quadratic equation, and if we solve this quadratic equation, we will get tan alpha is equal to either minus 2, 4, 6, 5, 6 or 1.8656. Here this we have to neglect because this is negative. and if we are taking the inverse of tan, we'll get alpha is equal to 1.0787 radians, which is equal to 61.83 degrees. So one of the option is 61.81. So the answer will be B, 61.81. Uh, yeah, so uh, this was the trial run for week 0. Uh, if you have any doubts or anything to share, which can lead to a better understanding of the course, feel free to post your doubts in the discussion forum, which is available in the course page. And we'll be having this session each week. My session will be on Mondays, 6 to 7. Uh, yeah, looking forward to meet you and have a good time. Thank you.
Thanks.